Welcome to chapter 3.2, which is called Integrating and Differentiating Vectors. Let's have a look at where it lies within the broader modulus. So we are here, right? Integrating and differentiating vectors. This chapter is the shortest chapter that there is in the whole modulus. So let's have a look at what we are going to do in this chapter. So remember I was telling you that calculus in higher dimensions, what is it all about? So first remember that in the first semester you learned about differentiation and integration. And the functions that you do, the differential and the integral, are this function f, which is a function of x, f of x, right? There is one single input and one single output. And during the rest of the module, we are going to be working in extending this. So we can have multiple outputs, we can have multiple inputs, or we can have both. And we are going to walk our way through this. So this chapter 2.1 is all about this second step here. And this is the easiest step one can make. So instead of having one single output, we now have a vector as our output. But we still have one single input, okay? So this is what we call differentiating vectors and integrating vectors. Please note that V here is in bold. It's written in bold, which means that it's a vector, okay? So we are doing the differential of a vector and the integral of a vector. Now, the reason that this chapter is so short is that I can get it done in 2 minutes. So let's do it. So a vector V is equal to Vx x hat plus Vy y hat plus Vz z hat. So starting from this point, the derivative or differential of V with respect to x is equal to d dx of all this, which I can copy. And since the derivative is linear, this is equal to d dx of Vx in the direction x hat plus dvx of Vy in the direction y hat plus ddx of Vz in the direction z hat. So that's how you calculate the differential of a vector. What about the integral? The integral of vector v with respect to x, this is equal to the integral of, I can copy the vector, of this with respect to x. But the integral is linear. Therefore, you can write that this is equal to the integral of Vx dx in the direction x hat plus the integral of Vy dy in the direction y hat plus the integral of Vz dz in the direction z hat. And that's it. With this, I could finish this chapter, and it would be enough for the rest of the module. Okay? Please note that the differential of a vector is itself a vector because it has vector components. Yeah, it has a x component, a y component, and a z component. And the integral of a vector is also itself a vector. So what am I going to explain in the following videos? So I'm going to just explain some details, like what is the meaning of these two things, and some tricky things that might happen when the vectors are not written in x, y, z basis, x hat, y hat, z hat. If they are written in other bases, such as cylindrical, then there is some trick that we need to do. Okay? So those are going to be the videos in this chapter. See you in the next video.